nPlan currently have risk analysis for individual projects, but no way of seeing it for multiple projects.
The challenge is to find a way to produce a portfolio view and to display it in an easy-to-interpret way.
I want an automated, standardized, and data-driven process to enhance how I can predict and manage risks across my portfolio of projects.
I want a way to view risk analysis over multiple projects so that I can make more informed decisions.
There is no way to group individual risk analyses.
Individual risk analysis isn't as useful for large insight as a portfolio view would be.
We are unable to see the potential value of a full portfolio risk analysis.
The dataset was generated from dashboard and machine-generated information and are stored in different spreadsheets and databases. Initial data analysis was done by Python and visualization was done with Power BI. The data was cleaned and combined into tables that provides logical flow for calculation and visualization. As the data came from different platforms, terminologies across different tables were being looked at and normalized so that information can be linked and used in the whole datasets. As the project names are anonymized, a table is also created for identifying the project names, and in this exercise, we have named them project 1 to 4. The dataset is large, and with duplication of activities names across all projects, the items were then summarized into projects, highlighting the high-risk items.
In parallel to looking at the data in Power BI, we also approached this by looking at the data in Python pandas. The NumPy files were converted to dictionaries. The different CSV files were appended. High-level exploratory analysis was undertaken to show frequency of the summaries across the whole portfolio and relationship between the plan duration and frequency counts. Given the modelling capabilities of Power BI, it was decided to progress our solution with that being the main tool.
From the data supplied by nPlan, we had summary data and schedule metrics data. We counted up the frequency of similar summary types, and we can see here that the number for project 2 and 3 was exactly the same in all of the data that we've got. And for project 4, there was unique data that was quite similar along a few different elements. In the middle, we've got a combined frequency here, where this is both the summary type frequency and the schedule P6 ID type together, and the bottom is the P6 type. We are showing the top 10 of all items by this summary frequency. If we wanted to see more, we can show all, but for the purposes of this analysis, we're looking at the top 10 for the maximum amount of insight. On the tables on the right, we've got row by row items of each summary type item, although it's been codified, total frequency, frequency per project, and a rank. The table below, we've got the line items from the P6 schedule, with also some performance metric indicators from there. On the right-hand side, there's a row by row of each common ID, i.e. the IDs that are in both sets. And at the bottom, we've got a percentage balance of each. So we can click on a particular project here, project 2, and everything on the page will update. However, if we go to these up at the top, instead of drilling down, it will highlight. The last thing on this page is we have 10-point criticality percentiles. So we can look at the top 90%, the 20 percentile, or the 0 percentile to see all of those. On the second page here, we're showing much of the same information, but zeroing in on the metrics data. So we've got critical float sensitivity, criticality, risk influence, and mean forecasted duration. We've also experimented with a hybrid risk factor by which we are multiplying different performance metrics. We've done a 1- forecast likelihood to give a positive factor from the least likely to maintain forecast, multiplied by criticality, critical float sensitivity, and risk share, etc., which is giving us some quite interesting information, showing that project 2 is by far the most risk. Project 3 shortly following thereafter. Project 4 is somewhere in the middle, and project 1 has very little in this respect. If I then show the top 10, however, because there's not a lot of continuity between both forms where the common IDs are, we can see the data in this hybrid risk factor is not quite so clear. It looks much better when we show all items. Again, we've got the balance of the risks at the bottom, so we can follow through and see how it is for each individual project here.
I now have a way to view risk analysis over multiple projects so that I can make more informed decisions.
With more time, we would combine the additional insight we have yielded from this hack challenge with the existing simulation models that nPlan already have in place to fully integrate any new insight into a complete data landscape. This would then further allow for Monte Carlo modelling to be conducted incorporating these additional insights.
Judge's question number 2, on how has the compilation of data been advantageous to the risk analysis process? The compilation of data has helped us identify common relationships across projects, enabling us to highlight and tackle those most frequent. That will in turn mitigate risk on a larger scale than just on a project-by-project basis. It also helps better management of resources to tackle risks and enables clients' and sponsors' aspirations for a portfolio view of all the risks.
It enables identification of common risks and early warnings across all projects, allowing common mitigation measures to be implemented. Lessons learned and monitoring or managing of risks across various projects enables more consistent delivery of all projects on time.